Hello. Here I want to consider the idea that variance hurts. And the particular innovation in this hip surgery process that I'm going to consider is to split up the group of patients which have a variety of BMIs into lighter BMIs and higher BMIs, with the hope that if I go back to my case, you may recall that the variance on the lower BMI patients is lower. And so it may be possible, let me just see if I can find that table here somewhere. Yeah, it's down here. You can see these lower BMI, the underweight, normal weight have standard deviations of around 5 to 10, whereas 10 is the minimum, if you go beyond that. So the question I have is, maybe if I allocate the lower BMIs to track A and the higher BMIs to track B, that I may be able to squeeze one extra surgery out of track A while not impairing the number of surgeries I get out of track B. So that's the thought. So you can think about this as sort of unpulling the customers, or pursuing this idea of maybe lower variance is going to help us without impairing what happens with the higher variance. Now there's a number of different ways to implement this. I'm just going to go with a two-way split: track A lighter BMIs, track B higher BMIs. But you could also try a lot of different other strategies where maybe in order of BMI through the week, Monday, Tuesday through Friday. You progressively get heavier in the BMI so that the lightest BMI folks are Mondays and so forth. And maybe you can get, a few more surgeries out of Mondays, Tuesdays, maybe even Wednesdays, without getting, dropping too far back when you have to deal with the morbidly obese folks. Okay, so let's have a look how this is going to work. I'm back at my base case. And again, I want to emphasize just a couple things, all these and this early stage solution development. I'm looking at, I have a bunch of knobs that I can twiddle. Each of these knobs are just being in a process innovation. So I'm looking to sort of unpack what the delta is going to be relative to the base case for each of these little changes. I'm not making multiple changes where, I'm unable to tease out, the effect of, let's say, this variance, this patient splitting proposal from, let's say, pulling the ORs from pulling the anesthesiologist. I want to analyze each of these in isolation. And then, once I figured out what seems to be delivering some value, come back in, make a composite scenario and run that for you. And I'll do that. I'll do one composite scenario to wrap up this playlist. So I want to show you a spreadsheet which lays out how I originally got, the 100.71 and 8.09 minutes. This is from a table given in the case. Let's close this. Okay, just zoom in here a little bit. So all I'm doing here, so I have these weights, 1% through 10% for these different BMI groups. And, the mean is just the weighted mean. And then to get the standard deviation, what you have to do is, so the variance is the square weighted sum of the variances. So for example, if I take the variance here, the variance would be 25. I have to square the weight. I'll write that out for you. So if I have a variance of A, some weight A times random variable X plus B times Y, this is going to be A squared variance of X plus B squared variance of Y. And I've applied this formula here to figure the variance. And then what I do is I just take the square root of that to get the standard deviation. Right, so that's the, and then, the corresponding thing for the expectation of the mean is going to be this. It's just A times E of X plus B times E of Y. This may be, expectation and variance of linear sums of random variables. Maybe something that you did in statistical analysis. That's what we're using here. Now, to get this to go with two BMI groups, exactly the same idea, but what I've done is I have taken the lower BMI folks here, and you can see what those weights look like. Just see if I can find the weights. Yeah, there it is. You can see that sums to 50%. So all of the underweight folks, normal weight, all the overweight folks, some of the obese, and then it just shows you how relatively obese and morbidly obese. So the bottom 50% are obese or morbidly obese, and that's the split. Now the key numbers that I'm interested in here, I'm going to just write them down because I need to have them appear on the screen. So track A is going to have a mean of 97.62, standard deviation of 679, let's say. And then on track B, they're going to be the heavier folks, 103.8 and 13.42. Now, whether this split makes any sense, it's just something we're trying to establish. So go into your model. Just try and move this so I can see it. Okay. Now, what I'm doing is I'm going down here and I'm changing my surgery time mean for A. So that is surgery time B. Where have I got? Here's okay. Surgery time mean A. I want to change that from what it was for the general setup for all patients. I'm going to make this one 679. So it is lower variance, also a lower mean. Hopefully I get an extra surgery out of that. And then hopefully I don't get killed down here where now I'm up to 103.8 and 13. Not quite a doubling of the standard deviation. And let's just run this. I do need to make sure that I'm back to there is 90. So I did clear out the previous change that we had with respect to the arrival rates. You'd have to run 3 to 5 times. I'm just going to run it one time. I'm not going to, investigate other splits like, the one that I mentioned where Monday through Friday, you're getting progressively heavier in the BMI, but you could certainly do the analysis, and it is in that spreadsheet that I just showed you. So let me go here and set this up to go to 570. And we run it. Okay, so I did get 4 and then 3. And you can see my flow times are 209 and 211. I've got the problem with the anesthesiology pool. So that is my bottleneck. The ORs are pretty heavily utilized also. So this splitting of the patients, lighter patients going to track A and the heavier patients going to track B really didn't address the bottleneck issue at all. But this is a possible variance reduction move, and it's possible that this, in concert with other innovations, could be helpful. It's a reverse pooling move, the one that does go after the variance reduction idea. Okay, so in the final clip, we're going to try and put some of these ideas together and see, what can be done.